Hello, 8th graders. Here is Digits 4-1, Part 2. I'm going to go over the key concept first before we go over Part 2, because the key concept is important for you to understand Part 2. Instead of clicking this and letting the person read it, I'm going to read this to you. It says, some numbers are so large or so small that they are difficult to write. You can use scientific notation to express such numbers, as they are easy to write and compare. Now, here's the rules for something in scientific notation, though. I'll let you know that this number down here, 6.92 times 10 to the fifth power, is written in scientific notation, just as it says down here. If you look diagonally, it says scientific notation. That's the same exact thing. All right, so scientific notation, this is the way it would be written in scientific notation. And also notice it's important that you understand 6.92 is larger than 6, but less than 7. So 6.92 is like $6.92. If you had $6.92, you wouldn't quite have $7. You would have more than $6, but not $7. So understand that 6.92 is more than 6, but less than 7. N times 10 to the fifth, you notice that this is what we call a power of 10, and it's raised to the fifth power. So that's important. I wanted to read that to you before I read this to you, because here's the rules for scientific notation. A number in scientific notation is written as the product of two factors, product meaning multiply. Two factors. Here's one factor in blue, the 6.92. The other factor, 10 to the fifth power. 1 greater than or equal to 1. So here's your number. So this is greater than 1 because it's 6.92, but it's also less than 10. So the number that you have has to be more than 1, but less than 10. And 6.92 fits there. 6.92 is more than 1, but it's less than 10. And the other factor has to be a power of 10. So when you see scientific notation, you have some sort of number that's greater than 1, but less than 10, and it's times 10 to some power. Okay, so 6.92 times 10 to the fifth power is the same as 692,000. And I want you to notice too, 6.92 times 10 to the fifth. Here's the decimal point. I don't see a decimal point here, but it does say to the fifth power. If I had 6.92 and I imagine that the decimal point is here, and I moved it 1, 2, 3, 4, 5 places, just like the fifth, I would get 692,000. So that's how standard form and scientific notation work together. Okay, so that's your key concept. Part 2 is rather short. It just goes into those kind of the concept of that scientific notation. All right, circle the numbers that are expressed in scientific notation. For the numbers not circled, explain why each is not expressed in scientific notation. So this goes back to the rules that you had in the key concept, that the first number has to be between 1 and 10, and the second has to be a power of 10. So 20 times 10 to the third. Is that in scientific notation? No, because 20 is more than 1, but it's also more than 10. So it can't be more than 10. So this one we'd have to say no, not in scientific notation. 5 times 2 to the 10th. Is that in scientific notation? Again, no, because although we have a number that is between 1 and 10, this is not a power of 10. This is a power of 2. So this one we would say no. 4 times 10 to the negative third. Would that be in scientific notation? Yes, because this number is between 1 and 10, and this is a power of 10. I don't care that the exponent is negative. We're allowed to have negative exponents as long as we have a number between 1 and 10, or 1 and less than 10, and a power of 10, we're good. So yes, scientific notation. 2.7 times 10 to the 120th power. Scientific notation, yes, because 2.7 is between 1, is greater than 1 and less than 10, times 10. This is a power of 10. I don't care that the exponent is really big and it's 120. Doesn't matter. It's still a power of 10, and it's an exponent, so we're good. So we would say yes, scientific notation. 4.22. Is that in scientific notation? No, it is not, because although this number, 4.22, is more than 1 and less than 10, it's not times a power of 10. 7.5 times 10 to the 0 power. Is that in scientific notation? Yes, because 7.5 is greater than 1 and less than 10, and it's raised to a power of 10. I don't care that the exponent is 0. You're allowed to have a 0 exponent. So we would say scientific notation. 10 times 10 to the 6th power? No, because remember, you can't have a number. The number has to be less than 10. This is exactly 10. 0.5 times 10 to the 2nd. Is that in scientific notation? Yes, because 0.5. Oh, I'm sorry. No. Oh, Miss Louie, you're making a mistake. So no. So this is not between 1 and 10. So no, not in scientific notation. So that disqualifies it. So if you have to go back over there, ignore my silly mistake there, not scientific notation. Okay, next page. So I would like you to work through this. You're allowed to look at the answer choices. Which of the following numbers are not expressed in scientific notation? So take the rules that we said there and try to figure that out. You can always click correct answer and solution. So your goal is to try part 2 today. So please watch this screencast as much as you need and then log back on and try part 2 yourself.